So thank you, Trisha, for the introduction. And so, yeah, indeed, today I'm going to talk about the kind of things we learn from looking at the data visualization and reporting from Develocity, so DRV. And since we've got 15 minutes, I'm going to dive straight in. So you may not all be aware of what DRV is, but so this is a new feature with Develocity that leverages the Develocity's APIs and gives you a set of pre-computed dashboards and queries to visualize the Develocity data. But so that means you're effectively looking at the entirety of the data through those dashboards, while a build scan is more focused on a single, build execution. And actually, Trisha, who just introduced me, had a blog post out a couple of weeks ago explaining the feature itself. So what kind of data do we have for Gradle itself? So I don't know if you're aware, but Develocity has a number of public instances for open source projects, and Gradle being one of those projects, we have an instance for Gradle, the Gradle build tool itself. So it's at ge.gradle.org. And so the kind of data we can find is like this overview that shows that over the last 90 days, we effectively uploaded 500,000 builds. And we've had like almost 10 years of build execution over 90 days. So it's absolutely massive in terms of data. I mean, the next slides are all blue because guess what? There are only Gradle builds out there. No Maven, no SBT, no Bazel, which shouldn't be a surprise for the Gradle build tool. And then you can see also that in terms of local versus CI, we have way more builds on CI. And that comes from the fact that on the Gradle side, we have quite an extensive test suites, which are mostly Gradle builds themselves. And so it takes a while to run all of those in the different configuration that we exercise in order to confirm that the developments are correct. So for the rest of the presentation, I'm going to just use 7 days of data because it's enough, and show you some of the things we've looked at in order to confirm is our build environment sane. So first thing that's really trivial to do with DRV is volume-based analysis. And so when you look at the type of a task and its number of invocations, so we're back to 7 days, right? And so we've got tasks that run more than 10 million times over a single week. And of course, when you look at tasks like creating a jar, compiling Java, class path manifest, which are internal things, process resources, Kotlin compile, that makes sense, right? Or at least it seems to make sense. But does it really? Are all these volumes coherent? Does it make sense that we have this task running that high number of times? And can we actually confirm that it's a valid execution model? And I don't know if you saw it in the list previously, but like we have that install sample task, which is kind of weird because this is not related to compiling code. It's a specific task related to our documentation that installs the samples in a way that we can test them. And samples need to be taken in a larger context. Every snippet that you see in Gradle documentation is actually a Gradle build that is tested to make sure that the documentation doesn't, rot in terms of examples. And so we have like almost 7 million execution over a week. How come? Well, if you go to a single build scan and search for that specific task, what you can see is that we have effectively more than 2,000 execution for a single build. And so if we do the math, well, what it means is that we run 3K documentation builds over a week. We probably will want to follow up on that because that's a lot. And so we need to make sure that we're not running documentation builds too often. Then if I continue, another very interesting information that we get from DRV is a high-level overview of the time different things take. And I need to give you a bit of context in Gradle's testing setup so that you can understand what I'm going to show you next. First of all, lots of the tests we have in Gradle are integration tests that are based on running a build, even if it's a small one. We also run them in multiple configurations. Gradle has a daemon mode, but we also need to check they work without the daemon, which often means a single run daemon. We have the configuration cache as a feature, so we want to make sure that all the features we exercise are compatible with the configuration cache. We're currently working on isolated project, which is an upcoming feature, so that's yet another dimension. But we also have one more runner, which is kind of something that existed for the longest time in order to simplify local development. We have that embedded mode. And the embedded mode means that we run the test in the daemon that's actually running the build. So we don't even spawn a new build, we really use the same build. But the idea behind that was to have faster to start, easier to debug tests. However, they have corner cases. Like there are some Gradle features that just won't work in that system because since you're actually in the build process itself, running the tests that are exercising the build, class loaders, all kind of things create some fun situation. And finally, recent developer surveys shows that sometimes they're a source of confusion for developers. And so we have questions in satisfaction survey that should we keep them? So what happens on CI? Well, on CI, quick test is the lifecycle task we use. It runs most of the integration tests in embedded mode. And we've got platform test, which is the forking mode. So we effectively have a real daemon running. So technically, of all the stages that I explained earlier on, configuration cache, isolated project, embedded test add one more stage. Is it worth it? Well, if we look at one of the Gradle module, the core tests, you can see the platform test at the top, and the average build time is 5 minutes, 4 minutes. But then you look at the quick test, and wait, these times are either very, very close or actually higher. Wait, didn't just say that they were supposed to be faster? And that was the main reason we were running them like that. You take another project like dependency management. So we run dependency management platform test as far as a longer invocation that runs more things. But there again, from 10 minutes, 7 minutes on Linux to the equivalent things with quick test where we're again really close. A couple minutes are saved indeed. But if you look at more and more of these modules, you realize that the balance between winning and losing time is actually not clear. And so it's definitely something that we intend to follow up upon because we now have actual data to potentially revise the existence of those embedded tests and make a decision. If they're not faster, do they still provide value, given some of the feedback we've had from the developers? The next one is negative cache savings. So with Develocity, you can realize that some of the tasks that you thought made sense to be cacheable are actually not giving you the benefits you expect when they're getting a cache hit, because fetching the result from the remote cache might actually be slower than re-executing the task locally. And so if you look at our build, I mentioned that class pass manifest task earlier on. We've got like nearly 10 million invocation a week. And what we can see is that out of the total elapsed time of 2 days and 7 hours, we actually have 10 hours. That ago is kind of a problem in the representation of the data. It's a date and it's negative. And so it's ago, right, in the past. But it means effectively we're spending 10 hours for nothing. Like restoring things from the cache while actually running it locally would be faster. Gradle build basics means it's a task defined in Gradle's own build and build logic. And so definitely we should turn caching off and see what happens. So yeah, follow-up is disabling the caching of that task. So dependency downloads. One of the reasons I'm here talking today is because when we looked at DRV data and some of the information that Hans shared at the keynote this morning, I remember seeing data from a customer, and they were spending like 50% of their time downloading dependencies on local builds with Gradle. I've worked in dependency management at Gradle, and I can tell you that one of the hard things we've tried to solve is that your local builds should not download dependencies. They should the day you update one, but otherwise that cost should be paid the first time you prime your Gradle user home, but after that, it should not happen. And so that 50% number was absolutely bonkers. And so one of the things I wanted to verify with DRV on Gradle's own build is, are we actually successful in that promise of, not having dependency downloads? So the CI strategy we have is not ephemeral. We have a fleet of long-lived agents. And so that includes things that ephemeral CI takes care of, like we need to kill processes and we need to clean up files. It's really fun when you have tests that tests failure because you've just made a file read-only, and then you need to delete it. So you first need to change it to writable again. All the mess that effectively ephemeral CI gives you. But one of the things we try to do is say, we have state. Gradle works really well with state. Let's see if we can leverage that on CI. We also have a fleet of on-demand agents, but even though they start fresh on an activation, they actually stay live as long as there are builds in the queue. And these days, it's pretty much all the time. So what does it mean, though, overall in terms of downloads? Well, we still download after half a terabyte per week, effectively. We have 1.6 million files downloaded, almost 2 days of download time. And if you count that wall clock, it's almost 20 hours. So, I mean, it's not nothing. What does it mean, though, in terms of build? Well, these are kind of all the builds, from CI, from global at the top, CI in the middle, local at the end. And the key element to realize is that the DRV dashboard is built in a way that for a build to show up here, it needs to download one file. And so if you remember, I showed you numbers with like thousands of builds, millions of tasks executed. And now we're like 500, 300. And so the reality is that our no download strategy is actually working because only a fraction of the builds do downloads. And if I take one example, like the docs test, we have 2K builds per week. By the way, that's a hint that there is a problem because these install sample pointed at 3K and we only have a bit less than 2K. So there is a mismatch there, like we need to investigate that. But out of those builds, only 300s downloaded one file or more. That's amazing. Like that, we're literally not spending time downloading stuff over the network. That's pretty much what I had for you. Other things that we figured out. So we still run, for example, older Gradle version in the 7X line. And we need to investigate that kind of things. We have data about smoke tests that are not using enough CPU time. Again, linking to what Hans was saying this morning. So we need to investigate, can we parallelize those more? So thanks. I'll be around for questions. And also we have currently a developer satisfaction survey running for the build tool team. So please let us know what you think of Gradle, how it works for you, and what are the challenges you have with it. Thank you very much.